All right, we're going to be looking at Part C, the practice problems from Assignment 8. So we're going to be looking at Assignment 8, Part C, practice. You're going to need your periodic table, preferably the one we labeled in class, where you have your energy levels, which are your rows or your periods that go across. Remembering that when the D level, it jumps down 1, and in the F, it jumps down 2. We're not going to go higher than 38 on our tests and quizzes. You might see some on practice problems, but as long as you can do up to element 38 in electron configuration, you'll be good to go. We have our Aufbau diagram, our Aufbau sequence here. It tells us the order to fill our electrons. And we have to remember the S block has 2 valence electrons. The P can hold up, not valence, sorry, 2 electrons. The P can hold up to 6 electrons. And the D can hold up to 10, and F can hold up to 14. Our S block is this P section here, also includes helium. Our P block, D, and our F block. So we're going to use this pattern as we are writing these. So the first one we're going to look at is going to be magnesium. I guess before we do that, just a quick reminder, electron configuration, we're looking at electrons, that tiny negative particle that moves around the nucleus. It has no mass and a negative charge. The arrangement of the electrons in the orbitals of an electron. So this helps us kind of know where are those electrons located. We're going to use 3 ways to describe that location. We're going to go from broad down to more narrow and specific. So energy level is going to be those rings around the nucleus. The sublevels are going to be what type of energy level you're in. And then your orbitals be the specific sublevel and like specific orbital where 90% of the time we can find those electrons. So in the first energy level, we only have S. The second has S and P. Third has SPD, and fourth has SPD and F. So that means we're looking at max of electrons in each one of these levels. S can hold up to 2, so it can have a max of 2 electrons. 6 plus 2 is 8, so the second energy level can have a max of 8. So again, these are my energy levels. 3 has 2 plus 6 is 8, plus 10 is 18. And then we have 2 plus 6 plus 10 plus 14 gives us 32. So that's the max number of electrons that you can have in each of those. And then we're also going to look at our valence electrons. And so our valence electrons are those outermost electrons or the electrons in the highest S and P orbital energy levels. So if I have an S orbital and I have an SP and an S, we're going to go with the one in the third. If we have a 3S, a 3P, and a 4S, we're only going to use the 4S. So it's the highest S and P orbitals. And then this would be my valence electron, that outermost electron. All right, so the first one up is magnesium. So we're going to use our periodic table. And so the first thing we need to do is we need to find magnesium on the periodic table. It's 12. I rounded the average atomic mass to 24. So we have a mass number there. We know that this is going to be an atom because it doesn't have any charge on it. So it means if it has 12 as the atomic number, that means 12 protons. So we're going to have 12 electrons. We'll come back to the valence electrons, and we're going to use this sequence. So we notice that it's in the third energy row in the S block, and it is the second one, 1, 2. So if I had to guess, it should end on 3s2. So let's check that out. 1s is what we have first, and we have 12 electrons that need a place or a home. So we're going to put 2 in here. That leaves us with 10. I'm going to show that by using a superscript. So my energy level, my subshell, and my number of electrons. 2s, S can fit up to 2. We have 8 more to place. Then we have 2p, and we have 8 left still, and this can hold a max of 6. Next is 3s minus our 6 gives us 2. So we have 2 left, perfect, because we can fit 2 in the S. So this would be the Longhand electron configuration for magnesium. Now we want to go through and check and make sure that we did this correctly, because sometimes you might mess up on counting the electrons. So let's count. 2, 4, 10, 12. Perfect. That matches our atomic number. That means we did this correctly. Last step is drawing our Lewis structure. So before we were drawing Bohr models where we showed we had 12 protons, 24 minus 12 gives me 12 neutrons. So there's my nucleus. We had up to the third energy row, and we knew that because it's on the third row. So we drew 3 rings. 1, 2, 3. And then I fill these in. 1, 2. Now we go to the second energy level. 3, 4, 5, 6, 7, 8. Third energy level. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sorry, my counting got weird. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Our valence electrons are those in the highest energy level of S and P. So our highest S or P right now is this here. So we're going to count up the number of valence electrons is 2. And we can prove that with this Bohr model because look, 1, 2 in the outermost shell are the highest S. So we have 2 valence electrons. So we're just going to write the symbol magnesium, and then we're going to put 2 valence electrons. So 1, 2. Typically, we're just going to move these all around. Sometimes you'll see some more advanced drawings where they put 2 together here and then spread them out to represent the orbital boxes. We're not going to go that detailed. So this is our Lewis structure, Bohr model, and our Longhand electron configuration. Let's take a look at phosphorus. We're doing the same thing. We need to find the number of valence electrons. The number of electrons, which is going to be equal to this number here of 15. You can also look on our periodic table, and we find phosphorus. It's in the third energy level and P block. So it should end in 3p123, 3p3. 15 protons means 15 electrons. We'll come back to the number of valence electrons, and we'll draw a Lewis structure in a moment once we determine our valence electrons. All right, so we're going to use our Aufbau diagram. We have 1s2. So now we're down to 13. 2s2. 11 left. 2p, we can fit up to 6, so that brings us down to 5. After that comes 3s2. Leaves us with 3, and then we have 3p3. 1, 2, 3, and we land at phosphorus. Now we're in column 5, so we should have 5 valence electrons, just like magnesium had 2, and it's in column 2. So let's count and double check that we did this right. 2, 4, 10, 12, 15. Perfect. And then how many valence electrons do we have? Highest S and P, 1, 2, 5. And it's in the 5th column, or group 15. So I'm going to draw phosphorus. I'm going to draw 1, 2, 3, 4, 5. All right. Next, we have vanadium. Vanadium is in our D block. It is on the 4th row, but the 3rd energy level, because you lose that 1 energy level here. So let's take a look at that. We have 23 protons, so that means we have 23 electrons. And then we're going to find our valence electrons, and then we'll do our Lewis dot structure. So we have 1s2. I guess we can also go ahead and guess. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1, 2, 3. So we should end in 3d2. So going all the way up to this part here. All right, 1s2. All right, we're down to 21. 2s, we can put up to 2 valence electrons. 2p, that one can fit up to 6, so we're left with 13. 3s2, 11. 3p, 6. We're left with 5. Now we can put 4s, 2. We're left with 3. 3d, that's what comes next, 3. Again, check your electrons. 2 plus 2 is 4, plus 6 is 10, 12, 18, 20, 23. Perfect. How many valence electrons? Again, remember it's the highest S or the highest P. In this case, it's going to be the highest S only. And so the answer is 2. And if you remember, I said all these transition metals all have valence electrons of 2. And the reason for that is because this S block is always going to be higher, and these always have 2 valence electrons, or always have 2 electrons in them. So it's just going to be 1, 2. So there is my Lewis structure. All right, let's do one more longhand before we add in the shorthand. We have germanium. So it is right here, atomic number 32. It has 32 electrons. And we will find the number of valence electrons. And then we'll draw our Lewis structure. All right. So you can use the periodic table and kind of figure it out, and then you can use the sequence to help you. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, back up to 4, 4p2. So we should end on 4p2. So 1s2, 2s2, so we're up to 4, 10. That can fit up a max of 2, 12, 18, 20, 30, 2. Again, let's double check. 2, 4, 10, 12, 18, 20, 30, 2. Perfect. How many valence electrons do we have? Let's go to that highest S and highest P. So we're going to be looking at 4S and 4P. 2 plus 2 is 4. And so the Lewis structure, which I'm actually going to bring it down here because we don't have a lot of space, is going to be germanium 1, 2, 3, 4. If we were to also draw out carbon, we would have found that carbon also has 4 valence electrons that look really similar, and so would silicon. So coming up in the next few days, we'll start looking at trends and how everything in the same column, they have similar properties. All right, let's learn some shorthand. So let's start with gallium, which is near germanium. It's 1 over 31. We'll round that atomic number up to 70. Okay. Now, we want to find the number of electrons is 31 electrons. We'll come back and find that valence electrons and our Lewis structure. I'm just putting this up here so we don't forget to go back and do that. And also we're going to do the shorthand. So everything is similar to what we've been doing. So we know that we're going to at least go to 3D10 because we just did germanium. So I'm going to go through that kind of quickly. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Remember, 3d10 can have, D can have up to 10, so we're up to 30. We need 31. So what comes next after 3d? 4p1. Double check. 10, 18, 12, 18, 20, 31. Now, that might get really annoying writing all that out. You will still need to know how to write longhand, but here is a shortcut. You go to your periodic table, you find gallium. We're going to go up. So So notice I went gallium, I just went up one row and then all the way over to the noble gases. Since everyone wants to be like the noble gases, we can use this in our shorthand because this has a full octet. And so we can show what the difference is where it's not full. So we're going to go gallium, up one row, all the way over, land on argon. Argon has 18 protons. So we're going to count 2, 4, 10, 12, 18. So all of this would be the same electron configuration for argon. So instead of writing all that out, we could just write argon 4s2, 3d10, 4p1. And you'll notice that we still have those valence electrons being demonstrated to us. So in this case, it's the highest S and P. 2 plus 1 is 3. So gallium is going to have 1, 2, 3 valence electrons. Let's look at our next example. All right, we have oxygen. So this one won't be as long because oxygen only has 8 protons. So 8 protons, atomic mass is 16. We use the one on the periodic table. Let's bring this just a little closer. Not sure if that helped you. This has 8 electrons, and oxygen is in the 6th column, so we are going to know it will have 6 valence electrons. We can also double check that when we do our electron configuration, and then we'll draw a Lewis structure. All right, so we have 1s2, 2s2, that gives us 4, 2p, we only need 4 more, so let's test it out. 1s2, 2s2, 2p4, 1, 2, 3, 4. Bingo! It's always great to play kind of like Battleship or something, or like playing bingo. So we landed on 2p4. Our highest S and P are 6, so that's perfect. And 2 plus 2 plus 4 is 8. So we did that correctly. Here is oxygen, 1, 2, 3, 4, 5, 6. Now oxygen, we go up all the way over and we land on helium. So I went oxygen up all the way over and landed on helium. Helium only has 2 electrons. So this isn't much of a shortcut, but it's still a little bit. All right, let's look at the next one. Krypton. Krypton is over here as a noble gas. It has 36 protons and 84 as the mass number, the protons plus the neutrons. So we can go ahead and write these out. It's going to have 36 electrons, 1s2, 2s2, 2p, p can have 6, 3s2, 3p, what will this be? 6, 4s2, let's see where we're at. We're at 4s2, so we're at 20. Double check, 2 plus 2 is 4, plus 6 is 10, 12, 18, 20. We need 16 more. 4s2, 3d10, 4p, and if we come here, 1, 2, 3, 4, 5, 6, it should be 6. So let's double check. 2 plus 2 is 4, plus 6 is 10, 12, 18, 20, 36. Perfect. And our highest S and P would be 8. So our valence electrons equal 8. That has a full octet, which is what all elements want. So it's very, very stable. We can write our shorthand for if it's already a noble gas, you can just write krypton. Isn't that easy? Because it is already a noble gas, you can just write that. And the Lewis structure would have 8 valence electrons around it. Sometimes you'll see this written with argon and they have 4s2, 3d10, and then 4p6, but I'm going to make it easy this semester and I'll let you use that method. All right, we have SC, so Scandinavian, should be, let's see if I can find it on here. Yeah, scandium, that's what it is, scandium. All right, it's number 21, and it has atomic mass of 45. So we're going to go 1s2, 2s2. We know we're going all the way up to 45 here. So I know I could at least go all the way to 4d. So 4d. So we're going to have to write all this out. So 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 4p, 5s, 5s, yeah, 4d, there. So 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d. And we're doing Scandinavian. Why am I going down here? We only have to go up to 3p or 3d. So I can scratch the rest of this out. We're not going that high. I don't know where I was going. Okay, so that's in the first thing, so it should end in 3D1. All right, I'm going to write it down here. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Let's double check. 10, 12, 18, 20, 21. Perfect. And then we can write our noble gas configuration, our shorthand, go up all the way over to argon. Argon is 18. So count 18. So 2, 4, 10, 12, 18. So all of this is argon. We're left over with 4s2, 3d1. And argon would have 2 valence electrons because the highest s is that 2. So 2 valence electrons. All right, pause the video and try the last few by yourselves. And if you have any questions, let me know. I have help sessions every Tuesdays and Thursdays. And I have from 1:30 to 3:30, and then on Wednesdays during your class period. So if you have questions on any of these, please let me know, and have a great day.